Jnanam paramam dhyayam. Knowledge is supreme.
Welcome to this course on advanced transition metal organometallic chemistry. We are discussing an interesting class of compounds. These are transition metal arene cyclopentadienyl complexes. Now, in our last class we had looked into preparation of these mixed arene cyclopentadienyl transition metal complexes, and what had come to the fore is the fact that there are quite many approaches for synthesis of this compound. So, synthesis wise these compounds provide very versatile approaches for preparation of these compounds. Now, among these approaches, one involved the conventional method, which included reaction of metal halides with these arene and cyclopentadienyl nucleophiles respectively. However, the limitation of this method was that the desired mixed transition metal arene cyclopentadienyl complexes were obtained in extremely low yields, about 2 to 3%, even much less than even 5%. So, even though the method the direct conventional approach did give the product, but the yield was problematic. And then what came to the fore is the fact that actually there are several other ways in which one can synthesize this kind of transition metal mixed arene complexes. And to start with, we looked at a method that involved ring expansion of a metal bound 6 membered benzene ring to a metal bound 7 membered benzene ring in a cyclopentadienyl metal benzene complex, resulting in cyclopentadienyl metal 7 membered arene type of complexes. We have also seen ring exchange, in which a ferrocene compound was taken and reacted with arene ligand, and was observed that one of the CP rings was exchanged with the arene to give the metal arene complexes. We have also seen the reduction with nucleophile in this arene metal cyclopentadienyl complexes, giving rise to cyclopentadienyl metal cyclohexadienyl type complex. We are also seen reduction at the metal. Then we had also discussed about these arene ruthenium cation unit transfer reactions, in which this arene ruthenium cation unit was transferred from a arene ruthenium chlorine dimer by treatment with thallium CP. And also lastly, we had seen that if one takes a cyclopentadienyl metal cyclohexadiene complex and then performs sequential hydride abstraction with trityl cation, then one can generate this transition metal arene cyclopentadienyl complex. So, the versatility of the synthetic methods for preparing this mixed arene cyclopentadienyl complex is something that we had discussed in great depth, and then we are going to look at the structure and binding of these kind of complexes. Now, as the name suggests that the cyclopentadienyl ligand can bind in a eta 5 fashion, whereas the arene would bind conventionally in a eta 6 fashion to the transition metal. However, these mixed ligand complexes can have examples in which these arenes can act as a bridging ligand. So, this is kind of interesting examples of mixed ligand complexes. Now, the conventional binding of this arene and cyclopentadienyl ligands in these transition metal complexes involved arene binding in a eta 6 fashion and cyclopentadienyl ligand binding in a eta 5 fashion, be the prominent method of binding. However, there exist examples of these mixed ligand complexes in which the arenes can act as bridging ligands. Can act as bridging ligands. In syn and anti coordination both. Now, this is illustrated by this beautiful example that involved trimerization of acetylenes, in which the benzene ring so formed is found to be bridging between two iron centers. H12 plus 3 Me at 20° centigrade gives this beautiful compound Fe and then each of the Fe is bound to cyclopentadienyl ligands. So, here is an example where the arene is bound as a bridging ligand, and they are happening to two iron center. Now, each of the iron center is bound bound to cyclopentadienyl system. Now, the triple Decker complexes of these mixed arene cyclopentadienyl transition metal complex have been synthesized, and the first examples of the first triple Decker complex involved bridging benzene. First triple Decker complex with bridging benzene. This is illustrated by this beautiful synthesis, which involved reaction of 2 C5H5 V C3H5 whole 2 in presence of 1 3 C6H8 at 100° centigrade, giving rise to this benzene being bridged between two vanadium center, one at the top, the other at the bottom, vanadium bound again to Cp. As is shown over here, and the distance between the vanadium to Cp is 192 picometer, whereas vanadium to benzene is 170 picometer. Another triple decker complex was prepared for chromium in a co-condensation method, as is shown over here, and this is an example of triple decker complex with only arene ligands, and this was synthesized by reaction of chromium gas with C6H3 amide-3 gas, and this co-condensation method giving rise to this beautiful triple decker complex of arene, as is shown over here. And this is a 30 valence electron compound, and the distance between benzene and chromium is 160 picometer, whereas from chromium to the bridging arene it is 170 picometer. So, with these we had come to the end of our discussion on transition metal cyclopentadienyl arene type complexes, and what we had observed so far is that these methods, these compounds are indeed special because they are mixed ligand complexes containing Cp and arene bound to the metal. The one interesting thing about this class of compound is the fact that there is wide versatility in the synthetic approach which exists in the preparation of these complexes. They can not only be prepared from a simple conventional route, but also can be prepared by ring expansions, reductions, as well as the abstractions, hydride abstractions, the ring the ring exchange, as well as the unit transfer type of reaction. So, there exists a wide variety of approaches that can give these desired compounds, and that is demonstrated by beautiful piece of chemistry. Each of these examples is demonstrated by beautiful piece of chemistry. Also, with regard to the structure and bonding, what we had seen is that apart from the conventional eta 5 binding of the cyclopentadienyl ligand and eta 6 binding of the arene ligand to the transition metal, these arene ligands can also exist as bridging and syn or anti fashion, and we had seen a beautiful example of dinuclear iron Cp complex in which the arene ring, hexamethyl benzene ring so formed during the part of the reaction is seen bridging between the two metal Cp units. So, it not only can exhibit the conventional eta 6 kind of binding, but they also can exist in bridging type of coordination. Another interesting fact about this mixed arene cyclopentadienyl ligand is what we had seen is that they can be used even to undertake lateral expansion, and as a result triple decker complexes in which the arene moiety was sandwiched between the two metal CP units or between two metal arene units are also synthesized, and that gives a glimpse of the rich chemistry that these mixed ligand containing CP and arene moieties to the transition metal can exhibit. So, with this we are going to finish talking about our this particular topic of transition metal CP arene complexes, and move on to another very interesting ligands, which are C7H7 ligands. So, these C7H7 as ligands, now they are 7 membered rings. So, we started off by looking at 5 membered CP, then we looked at benzene C6H6, and then moving on to look at C7H7 as ligands, and these are iso pi electronic series with C5H5 minus or C6H6 or C7H7 plus. Now, all of these are having the 6 pi electrons, which makes the ring aromatic, and that is why it is C5H5 minus, C6H6 or C7H7 plus, and it is why these systems are called iso pi electronic series. Also interesting in the fact that in eta 7 bound C7H7 complex, the tropylium character, that means the cationic may not be necessary. So, this is an interesting thing that they can bind in an aromatic planar way or otherwise as well. So, the tropylium character may not be necessary. The cycloheptatrienyl and cycloheptatriene. So, now there are two forms, what is called cycloheptatrienyl, which is C7H7, and cycloheptatriene, which is C7H8, readily interconverts, can readily interconverts, and also early transition metal prefers eta 7 C7H7 and eta 6 C7H8 complexes. So, these are just some of the salient features which are characteristics of C7H7 ligands, that they are isoelectronic with other systems like CP as well as CP minus as well as benzene in its C7H7 plus form. The C7H7 binding need not be tropylium all the way, and also there can be a exchange of C7H7 to C7H8, and also early transition metal prefers both C7H7 and C7H8 bound in a eta 7 fashion. So, these complexes come around in many, there are a lot of examples of this. We are going to be taking a look at some of them. For example, C7H7 C5H5. Now, this is exactly similar to the mixed cyclopentadienyl arene complexes of benzene that we have spoken about. In this case, instead of benzene, we have C7H7. This is quite common for titanium, vanadium, chromium, molybdenum, tungsten, cobalt. Then one can have C7H7M, C5H5 overall cationic species, common for vanadium, chromium, manganese. Then bis C7H7 whole 2 V 2 plus, this is the base of C7H7 bound to vanadium 2 plus. Then comes C7H7MO C6H6 plus. So, this is 7 membered ring, 6 membered ring mixed ligand system with molybdenum. C7H7M CO3. This is syn for vanadium, manganese, rhenium, cobalt. C7H7 iron, CO4. Then C7H7 Re CO3 minus, and then C7H7M CO3 plus, can be chromium, molybdenum, tungsten, iron. So, what emerges out is the fact that a large number of different types of compounds can be observed for this C7H7 ligands. For example, it can be bis homoaryl kind of system where you have same C7H7 whole twice vanadium, or it can be various heteroleptic system. You can have a 7 membered ring, 5 membered ring mixed ligand system. You can also have a 7 membered ring, 6 ligand ring mixed ligand system. You can have C7H7 carbonyl compounds, which are half sandwich compounds of this type. So, basically what all these is pointing to is the fact that C7H7 indeed is important ligand in the area of organometallic chemistry, and that they do have very many complexes which sort of makes them sufficient in number to be taken note of and be treated separately as a new class of ligands. So, because of that reasons, we are just continuing our discussion on C7H7 type complexes. And now, there are some examples of C7H8 complexes. So, the examples of C7H8 complexes are whole 2 M, M is zirconium, molybdenum, C7H8 M with C5H5, cobalt, rhodium, C7H8 M CO3, that can be chromium, molybdenum, tungsten, iron, ruthenium, and mu C7H8 FeCO3 whole 2. This is a bridging compound. So, what we see is that C7H7 can have many complexes, as well as C7H8 also has similar complexes, and that is why these merits a proper discussion. So, now let us take a look at the preparations that are available for the C7H7 complexes. And one method that is conveniently used over here is this substitution reaction. So, in this case the reaction metal carbonyl like VCO6 plus C7H8 at 65 degree centigrade eliminates CO as well as hydrogen to give this seven membered C7H7 V CO compound, and some byproduct is also formed which contains C7H7 V C7H8 cation and VCO6 anion. Another method involves the reaction of a cyclopentadienyl vanadium carbonyl with C7H8 giving thus rise to CP vanadium C7H7 ligand, and this reaction is also part of substitution reaction. So, this is C5H5 vanadium CO4 plus C7H8 at 120 degree centigrade giving CO minus H2 CP vanadium this 5-membered 7-membered vanadium compound. So, this also is a very interesting example in which this mixed 5-membered 7-membered compounds of 7-membered ring compounds of vanadium were synthesized. We are going to take a look at another interesting example which involves this reaction of MCO6. M can be chromium molybdenum C7H8 hit giving rise to this compound MCO that with the abstraction of hydride pH 3 plus giving rise to this 7-membered metal CO overall cationic in toluene heat gives a toluene complex M is a beautiful example where one can see all application of these abstractions, ring hydride abstractions. M is equal chromium, molybdenum, tungsten, and then hydride abstraction as well as ring displacement. And one can take this for tungsten M equals W in presence of RCN and heat, one can generate this compound WRCN whole 3 CO3. R can be methyl, ethyl, propyl, and then treat that with C7H8, giving back to this compound where M can be chromium, molybdenum, tungsten. So, this is a beautiful demonstration of the power of chemistry, in which several synthetic approaches, some involves thermolytic cleavage, some involves the hydride abstractions followed by ligand substitutions, giving rise to this mixed 7-membered, 6-membered complexes for a series of metal, mainly chromium, molybdenum and tungsten. So, with this I would like to conclude today's lecture. In today's lecture, we have discussed about the structure, particularly of transition metal cyclopentadienyl type of complexes, how they can act as a bridging, the arene ring can act as a bridging ligand between two metal centers, or act as a bridging ligand in a triple decker complexes, and then subsequently start our discussion on C7H7 complexes. And what we found that these C7H7 complexes by their own right and merit deserve a special mention, because a wide variety of these complexes are formed of these C7H7 ligands. Not only of that, but they can also be observed of C7H8 ligands, where there is heptatriene as well as cycloheptatrienyl in C7H7. And then we have looked into various synthetic methods which are available for preparation of these C7H7 and C7H8 complexes of transition metal, and we have taken up our discussion on particularly the substitution reactions, in which we have seen that metal carbonyls can be used for substituting in this C7H7 ligand by virtue of C7H7 ligand displacing carbonyl ligands, giving rise to the C7H7 complexes. And then we have looked into two such examples, and would continue doing so more on the C7H7 preparative methods in the subsequent lecture. So, till that I thank you again for patiently listening to me in this topic in today's discussion, and hope that certainly hope that you would join me when we take up our discussion on C7H7 in more detail, starting from their other methods of preparation, structure and reactivity in the subsequent class. Till then, goodbye and thank you.